Uh, in this session, we will continue studying about digestion, which is the second stage of the process of nutrition in human beings or in holozoic animals, animals that take food inside the body. Now, we've done esophagus in our last video. We've also studied the first stage of digestion that takes place in the mouth because of the presence of salivary glands, the secretion of the salivary gland that contains a digestive enzyme called salivary amylase digests starch, which is a carbohydrate, into maltose, which is a simple sugar. Now we'll continue with our the previous session on digestion, and the next part of the human digestive system that is involved in digestion is the stomach. And stomach is here, and there are a couple of features of the stomach. And the first feature is its shape. It's like a bag. Okay, so the first job, one of the most important jobs of the stomach, is to store the food that gets inside our body. So the stomach can actually store food for 4 to 6 hours, 3 to 4 hours. Uh, the next feature that we must now look at is that the stomach has gates. It just doesn't allow food to get in. I've just magnified the image and I'm going to show those two gates. So here, let me choose a marker first so that I can just show a couple of things. I love yellow, and let's draw something here. And so this is the bolus that is in the esophagus. So here is the esophagus. Now as the bolus is moving down into the stomach, it simply does not drop down. There is this narrow passage, a narrow path, which can be completely closed. This path can actually be closed completely like this. And this particular area or this zone here is called a sphincter. A sphincter. Now this term might intimidate you, it might scare you, but there is nothing that you need to be worried about. I'll tell you what sphincter is. Sphincter is a difficult word used to describe a structure which simply is nothing more than a gate. So the stomach has two gates, right? Kind of two doors. So this is the door, entry door, and here we have another sphincter which is the exit door. Now the bolus that is in the esophagus is not freely allowed to get inside. Why is something we'll study in a little while. Also, when the food is inside the stomach for digestion, it just does not flow outside freely. It is also stopped. So we've got like two gates, and the gates are called sphincters. We'll get into their function in just a little while. Now let me just demagnify the image so that we can study the details of the stomach in a little more. So we've just done what sphincters are, and another feature of the stomach is that the stomach is a flexible organ. It is not a solid structure. It is a solid structure, but it is not a rigid structure, which means its shape, its size can change. Now why is the stomach built like that? Why has it evolved to change its size? It is because the amount of food that you eat can vary. You can eat a little food which will fill your stomach. You can eat a lot of food which will fill your stomach even more. You can add water to that. So the stomach must expand. And what allows the expansion of the stomach? Now stomach can expand because of the folded inner wall. So this is the inner wall, and can you see those folds? And all of these folds allow the stomach to expand more. And these folds in the inner wall of the stomach are called rugae. Rugae. Rugae, again, a simpler term for rugae can be folds. So rugae are nothing but folds that increase that allow the stomach to expand in size. Also, the folds allow the stomach to produce more digestive components, which we will study in just a little while, in just a teeny weeny little while. Now, the next aspect that we should know about the stomach is that it has a maximum capacity of 2 to 4 liters. Now, how much is 2 liters? Now, 4 packets of milk, 4 packets of milk that you get in the market, the 500, the half-liter packet that you get, 4 packets of milk make up 2 liters, and 4 liters is 8 packets of milk that you get in the market, right? So this is the maximum amount that the stomach can store in adults, not in kids but in adults. Some adults can store a maximum of 2 liters and some can store a maximum of 4 liters. Now also the walls of the stomach, again let us magnify and let me tell you where the wall of the stomach is. Now you see this area here, let me use this pointer, this area here is the wall, and the wall has two parts. So this is the outer wall. Let us just choose the marker or the pen, the writing tool. So here this is the outer wall and this is the inner wall, the outer wall and the inner wall, and in between these walls here are muscles, lots of muscles and lots of muscles. And what are those muscles actually doing there is what we'll see in just a moment. These muscles are there to make the stomach move. The stomach is always in motion. Now we may not feel it, we actually do not feel our stomach moving at all, but as I speak and as you're even watching this video, your stomach is moving phonetically. Now what is the nature of movement? Now I hope remember how the bolus or the ball of food moves down the esophagus. The bolus just does not fall down. It just does not fall down into the stomach. Rather, the muscles in the walls of the esophagus. Now, what I've drawn here, figure 1, is esophagus, and this is the bolus, and these yellow lines are representing the walls of the esophagus. And the muscles in the walls of the esophagus contract, they become narrow, and then they relax, they come back to their original position, and then they push the esophagus like this. You see, it has become narrowed because of the muscles squeezing the esophagus, and this is the bolus. And so the bolus is then pushed downwards towards the stomach. So this wave-like motion, and let me just tell you what this is. This wave-like motion in the esophagus, see, it's a wave-like motion in the esophagus. Here, let's use the pointer. This wave-like motion, right? The wave-like motion in the esophagus that pushes the bolus towards the stomach is called peristalsis. It's called peristalsis. You have to remember a couple of terms, and we'll come back to the terms that you must remember in just a little while. So let me just write number 1 here so that you don't forget it. So peristalsis is the wave-like motion in the esophagus produced by the action of muscles in the walls of the esophagus. And what is the function of peristalsis? To move the food down in esophagus. But in the stomach, again, such peristaltic movement, such peristalsis or wave-like motion takes place in the stomach. Why? Is for 2 reasons. One is to mix the bolus that gets inside. The bolus that gets inside the stomach, the first is to mix the bolus with the secretions of the stomach. That is the first function of this motion produced in the stomach. And the second function, why the stomach is in motion, is to grind the food. Like our teeth grind the food really well because they're very hard, but the stomach basically mixes and churns them and makes the paste even into a finer paste. So these are the 2 functions of the muscular movement of the stomach. Also, another function of the movement of the stomach is in the later stages of digestion, the stomach can push out this material into the small intestine. So once again, let us look at the 3 functions performed by the muscular movement in the stomach. First is mixing of the food with the secretions of the stomach, the digestive juices of the stomach. Second is to make the bolus into even a finer paste, and third is to push this bolus. We don't call it bolus anymore, but what do we call it is something that we'll just come at in a while, and to push this digesting food, not digested but digesting food, into the small intestine. That is the third function. So far we've understood a couple of things. It's a bag, it has 2 gates called sphincters, the inner wall is highly folded. Why is it folded? We've studied. It is a flexible organ to accommodate more food. It has a certain capacity in adults, 2 to 4 liters maximum. The walls of the stomach has muscles. And now let us watch a video on this particular thing, the movement of the stomach. So I'm just going to play it from the very beginning, and you have to bear with me a little. So Let's start from here. So I hope you can see the wave-like motion. So this is the inside of the stomach. You see the wave is coming? See, that's the wave moving downwards from the esophagus down to the intestine. And see, if there was food, this is an empty stomach. There's no food in the stomach. And this is a video. It's called an endoscopy video. And see, another wave is coming down. So these waves not only mix the food, but they also food push downwards. They mix the food with the contents of the stomach, and this keeps happening for like 2, 3, 4 hours. And for all that time, your food is inside the stomach. So just think how hard the stomach is working, and we don't even realize it. Anyways, the video is going to come to an end. This is a peristaltic wave. Just remember that. All right. So now we'll just go back to our whiteboard and we'll study more. So the walls of the stomach has muscles which are responsible for peristaltic movement. So peristalsis happens in the esophagus. It also happens in the stomach. Why? Because there are muscles. Now we'll go to the next aspect, which is the inner walls. Let us just clean the board a little bit so that we can make it a little bit tidy. We'll just keep the bolus out there. And so, okay, I should have kept the gates, but anyways. So the inner wall, and let us look at the inner wall. So this surface that you see here, all of this here is the inner wall, the highly folded inner wall. So the inner wall of the stomach produces a couple of very important chemical compounds. And what are those important chemical compounds? Number one, the stomach produces hydrochloric acid, HCl. Let's use a red marker. So it produces hydrochloric acid, HYDR, hydrochloric acid. So this is the first very important chemical produced by the stomach. The second secretion of the stomach is called the mucus. We'll come to each of them one by one. And the third secretion of the stomach is something called as a pepsinogen, P-E-P-S-I-N-O-G-E. And I shouldn't be writing it, how foolish of me, but anyways, as I've written, it's alright. So the third secretion of the stomach is called pepsinogen. And what is pepsinogen? Pepsinogen is a digestive enzyme. We'll come to each one of them one by one. And let us start with hydrochloric acid. Let's start with this chemical here, HCl for short, hydrochloric acid. Now, hydrochloric acid, before we study hydrochloric acid, I would like you to please go through this video, another video, which happens to be a very interesting one. What does hydrochloric acid do to food inside our stomachs?
There's some fumes coming out of this. There we go, good old McDonald's cheeseburger. Still warm. Just tempted to eat it. Okay, so we're going to leave our burger to digest for a while in the acid. Come back later and see what's happened.
Unlike most of the chemicals I talk about, I can be absolutely sure that every person watching has a sample of hydrochloric acid with them as they watch, because hydrochloric acid is found in everybody's stomach and it's part of our digestive process. So as you're watching me, churning away in your stomach is hydrochloric acid, which is one of the first stages in which food is broken down into usable components to give you energy or make you fat.
It's 3.5 hours. So we're going to see what happens to a tasty McDonald's cheeseburger after 3.5 hours of concentrated hydrochloric acid. Okay. Ooh.
Oh my God.
I think it's absolutely disgusting. Ugh. Ugh. So I mean, the fats aren't really going to dissolve very well because in your stomach there's lots of bile acids and thing in your actual body to do digestion. This is just pure HCl.
So I'm sure you would have liked this video. You would have really learned something from this video. Let's just go back to our whiteboard. So hydrochloric acid, what it just did was it solubilized the food. So let's write HCl here and try to understand a couple of functions. So the first important function of hydrochloric acid is to solubilize food chemically. What do I mean by this is that it's a chemical and it is going to dissolve the food, right? So the complex components, the larger components are broken into simpler, smaller components. That is what it is doing. Second thing, what it does, hydrochloric acid does, it's a very important function of hydrochloric acid, is that it protects you from germs that enter your digestive system through food or through water, and even occasionally through the air that we engulf inside our body, through the esophagus. Yes, that may sound strange, but that does happen. So the germs, which are the bacteria or the fungi or the virus, etc., that get inside the stomach with the food and can cause diseases, are basically killed by this strong acid. So second function is protection from diseases, protection from microorganisms. That is the second function of hydrochloric acid. Third, very important function of hydrochloric acid is related to pepsinogen. Let us just come to pepsinogen now, and we will do the third function of hydrochloric acid and pepsinogen together. Now, this secretion of the secreted content called pepsinogen, it is secreted by the inner wall into the chamber, into the stomach. This particular pepsinogen is a digestive enzyme. It is a digestive enzyme. What is an enzyme? I hope you remember. Enzyme are special types of proteins. These proteins increase the speed of chemical reactions that take place in our body. Anyways, so pepsinogen is a digestive enzyme, but unfortunately pepsinogen is always inactive. It cannot act. But when does it become functional? See, it's like a car which is there, but unless and until you have a key to start it, it wouldn't start. So what is the key for pepsinogen? Pepsinogen can be activated. It is inactive, but it can be made active only when hydrochloric acid is present. So if any time there is hydrochloric acid around pepsinogen becomes active, and the active pepsinogen is called pepsin. The active pepsinogen is called pepsin. When I say active pepsinogen, I mean to say pepsin, which can then perform digestion. Now, what does it, let us first of all write down the third function of hydrochloric acid, which is to activate pepsinogen to pepsin. I know you people are really scared of all of these terms, but we are going to revise them soon. So don't be bothered. It's alright if you don't remember all of them, but you should know what is happening inside. The process is more important. Coming back to pepsin. Now, activated pepsinogen is called pepsin, and what does it digest? What does this digestive enzyme digest? It breaks down proteins that we consume. In our food, we have a lot of proteins, and the proteins are broken down into amino acids by pepsin. So that is an important function of this protein called pepsinogen. So so far, what is happening in the stomach? What part of digestion is happening in the stomach? The solubilization of food. All the different components are becoming soluble, and second important function is the proteins are being broken down into the stomach. So these two major processes of digestion are taking place inside the stomach. Now we'll go to the third component, the last secretion of the stomach. Now always remember, the inner wall secretes hydrochloric acid, mucus, and pepsinogen. The third component is called mucus. Now let us just make a little space for ourselves here, and I'm going to remove these tick marks, and let us just remove this block here. Or maybe we should keep it. Let's use another page. Let's use the next page. We got so much here. Let's use another page. Let's add another blank page. Now what is the function of mucus? M-U-C-U-S. Now, I hope you realized that hydrochloric acid is such a strong acid that it dissolves everything. So why doesn't it dissolve the stomach itself? What is protecting the stomach? Now the stomach is being protected by a layer of mucus. Now I want you people to roll your tongue back into your mouth towards your nose, back into your mouth towards your nose, which is basically the roof of your mouth. To the back, to the back. I'm also doing it, and you will find a slimy coat out there on the roof of your mouth, and that slimy substance is called mucus. Now this mucus is secreted by the walls of the stomach, and let's use this yellow marker to show the mucus. So the mucus lines the walls of the stomach like this, and all the acid, let's now use blue to show the acid, and all that acid cannot come in contact with the line of the stomach, and that's how the mucus acts as a barrier, acts as a wall, does not allow the acid to get in touch with the wall of the stomach and protects it from being digested or solubilized by hydrochloric acid itself. Now a little amount of this mucus is also present in the esophagus. Oh, I've just drawn the acid. Let's take back the acid. We were using the yellow marker for the mucus. So mucus also lines a bit of our esophagus. Let's go back into the previous diagrams. So and magnify a little bit into the esophagus. Let's go to the esophagus. Now a certain part of the esophagus is also lined by the mucus. Yeah, because sometimes accidentally what happens, this acidic content can move upwards into the esophagus, so the esophagus can also get damaged, right? So there's a little bit of mucus out there to protect us from this acidic content. Now we are left out with a couple of other functions, and we'll just go to that, a couple of other features of the stomach. Now coming back to the function of the sphincter. Now I hope you remember what sphincter was, this particular gate, and then we have another sphincter here, right? So what are the roles, or what is the role of the sphincter? The sphincter actually acts like a gate which does not allow, it stops this acidic content to come up. So if it is closed, the acidic content, food mixed with acid, cannot come up. In some cases, in people just like me, I was coughing a little while. I'm coughing because I'm suffering from acidity. What does that mean? It means I've just had my food and I had a cup of coffee, and my stomach is churning, and there's this wave of peristalsis, so there is kind of a storm inside. All right, so this acidic food has basically moved upwards. Let's use a marker. I'm making it really untidy, but that is how I work. So this chyme just moved up, and unfortunately my sphincter here has not closed up completely. It is closing, but it has not closed up completely, and that's why this acidic content has moved up, and it has moved up where? To my throat, and now it is irritating my throat, and I'm getting that cough. You see, this is called acidity. So I'm suffering from acidity. Right, so if the sphincter does not close, the acid travels up into the esophagus and can cause damage. Now how do we basically get over acidity? Is that we consume something called as Digestion gel, which is a base which will neutralize the acid, which we'll study in chemistry, and we won't do it here in this particular lecture because it's gone awfully long. So we'll just come back to the very basics, and there's this one last term that you need to now understand, is a term which we call, let's just demagnify it and place the slides absolutely straight somewhere. Now there's just one last term that I want you people to learn, and that term is called chyme. C-H-Y-M-E. Now we eat food, right? We eat food. Food gets into our mouth, and when it is out here it's called food. But when it gets down into our esophagus, what do we call that food? We call that food as bolus. So we got food here. Oh, what am I doing? I'm just using the wrong kind of writing. So we have got the food in our mouth. When it gets into the esophagus, we call it the bolus. And when this bolus reaches the intestine here, the stomach, I'm very sorry. And when this food reaches the stomach, and is mixed with hydrochloric acid, mucus, and pepsinogen or pepsin, this acidic content food now is called chyme. So, food in the mouth, bolus or ball of food is called bolus in the esophagus, and the same food when mixed with acid and other secretions of the stomach is called the chyme. So very rapidly, we'll just take 2 minutes to revise all the terms that we've done so far, only the basic terms and their meanings, so that you don't feel intimidated or scared by it. So the first term, let us go to peristalsis. Peristalsis, the wave-like motion in the esophagus or the stomach that pushes the food or the bolus or the chyme is called peristalsis, right? The next is sphincter. Sphincters, there are two sphincters in the stomach. Sphincters are gates or door-like structures. And then let's go to the next one, which is hydrochloric acid. It's another term, hydrochloric acid. It's just an acid. Then we've got the term called mucus. We've got pepsinogen. I should be using a marker. Let's use a marker to highlight all of them. And let me use this blue marker. So we got the, oh, this is too ugly, so let's use a lighter one. Maybe brown will work well. Maybe brown will work well. Let's just see. It works well. So yeah, so we got peristalsis is the first term. Second term, we've got sphincters. Third term, hydrochloric acid. Fourth is mucus. Fifth is pepsinogen. Sixth is pepsin, right? Then we got amino acids, and I believe that's it. We don't have any more terms. Do we have? Oh, we've got rugae, the folded walls, and that's it. So with this, we have come to an end of digestion in the stomach, and I hope that you learn something out of it. Thank you.